one page and your one chapter will be sorted. So each and every element in nature is made up of matter, and matter is made up of atoms. So atoms are found in both living and non-living things. An atom is the smallest unit of matter. But the question is it indivisible or it can be divided further, which we'll be studying in this chapter, which is Journey Inside the Atom. So, starting with the rediscovering the roots of atomic theory, which dates back to about some 2000 years. So, it can be seen in both ancient India and in the ancient Greece. In ancient India, the concept has been started by Acharya Kannada, who named it as Dravya, which is the matter, and Dravya is made up of Paramanu, which he spoke about like an atom. While in the ancient Greece, the concept was first studied by Leucippus and Democritus, who have named them as atomos, which means indivisible. So, but these all are the imaginary ideas, but not the experimental observations. But the first experimental observation was given by Dalton, John Dalton, with his Dalton's atomic theory. He proposed that all matter is composed of individual particles called atoms. That is, the atoms are the fundamental units, that is, building blocks of matter that cannot be broken down into smaller parts. Even though this was proved to be false in the later stages, but for the initial breakthrough, Dalton's atomic theory has been a major breakthrough in the concept of atom. So then we go through the journey of the atomic models. So with this we have got to the introduction of radiation and then the radioactivity. So starting with J.J. Thomson, it started in the year 1897. So he had started doing an experiment with the cathode ray experiment by using electrodes, that is the negatively charged cathode and positively charged anode, and a high voltage power supply. So this has given rise to the cathode ray, which he has noted it to be as the negative one, which is later named as the electrons, which has passed through from the cathode to the anode. So these negatively charged ones have found that their charge is about minus 1.602 into 10 to the power minus 19 coulomb, which we take it to be as approximately minus 1 for easy calculations. So but what about the stability? Because an atom cannot continuously consist only in negative charge, but it is stable. So why is it stable? So then J.J. Thomson has come up with the plum pudding model. He has told that the whole of the atom is like a positive sphere and the negative charge will be embedded in it. So it is like a plum pudding where the everything here is the positive charge, while the plums were taken to be as the negative charge. So like this J.J. Thomson has come up with the plum pudding model. But later in the year 1911, Grigor and Madison, who are working under Rutherford, have done the gold foil experiment. So they have taken the alpha particles, which are the nucleus of helium, which that means it consists of two neutrons and two protons, which we'll be studying later. So they have taken the alpha particles and they have bombarded them on a thin gold foil. So they have thought that most of this will either go with slight deviations or will go undeflected. But to their surprise, they have found out that Thomson's model has failed to explain the results of this gold foil experiment, particularly the deflection of some alpha particles through large angles, and most of the alpha particles have passed undeflected. So due to the deflections which they have found, which is known as scattering, so this experiment was later called to be known as the alpha ray scattering experiment. So then Rutherford has come up with the model of Rutherford's model of an atom. So he has concluded that the charge of the atom is not spread throughout but remains in a concentrated part, which is the extremely small region, which is known to be as the nucleus. So he has also told that the diameter of an atom is 10 to the power minus 10 meters approximately, and the diameter of nucleus is 10 to the power minus 15 meters. You can take that as the atom to be as a cricket ground and this to be as a 1 the pepper grain in it. So that is amount of the difference in the diameter, that is the size of the atom and the nucleus. But Rutherford model wasn't able to explain why atoms are stable, because according to Rutherford, he has told that the atoms will be rotating around the nucleus, and this was named to be as the planetary model of atom as well, because the planets also revolve around the sun in the same motion. But when such electrons are moving around the nucleus continuously, why is it that they're able to stay stable? But because they are moving, it means that they are accelerating. When things are accelerating, they'll be losing their energy, and ultimately they'll go and fall into the nucleus. But that is something which is not happening in case of the atoms, because they are intact. So why is it so is not explained in Rutherford's model of an atom. But Rutherford was the one who has discovered the proton, which is the positive charge of the atom. So Rutherford showed that the positive particle, which is called the protons, which is present in the nucleons, and an atom to be electrically neutral, is that the number of protons must be equal to the number of neutrons. Then only the atom will be electrically neutral, is what Rutherford has observed. But to overcome with the limitations in Rutherford's model, Niels Bohr has come up with the Bohr's model of the atom. So according to this Bohr's model, electrons flow in fixed circular paths, which are called the orbits, shells, or stationary states. In each shell, an electron has the definite amount of energy, which is called the energy levels. So here we can observe that he has named each and every shell. The one which is closest to the nucleus, the orbit which is closest, is named as K, then L, M, N, and so on. And he has also noted that N is equal to 1, 2, and 3. That is, we can take K to be as 1N, that is K is equal to 1. So the shells represented by the electrons moved in the allowed shell, and they do not lose energy. So this is the postulate which Niels Bohr has proposed based on the stationary states 1, that each shell can hold certain number of electrons only. And if the electron will move from one orbit to another orbit, it will either absorb or release energy. So this amount of energy which is absorbed or released will depend on the difference between the energy levels. And also, he has also mentioned that K will have the least energy, because the one which is closest, the orbit which is closer to the nucleus, will have least energy. The energy will increase with the increasing energy levels. And he has also proposed the stationary states postulate, but these limitations, there were even limitations for Niels Bohr's model of an atom as well. So in order to solve these limitations, the further proposed one is the quantum mechanical model, which you will learn in your later grades. So with this, we can understand the journey of the atomic models. Now, when we see that the whole mass in an atom is that which is present in the protons. So the protons one is taken to be as the mass of the atoms, because electrons are so light in weight that they are negligible. But when they only calculate the protons as the mass, it is not equaling to the actual mass of the atoms. So then they have found out what components actually contribute to the mass of the atom. So then comes the discovery of the neutron. So this was discovered by James Chadwick, who was also a Rutherford student, who has discovered a new subatomic particle. So the neutrons are found in the nucleus of all except in hydrogen. So then they found that electron will have -1 charge, proton will have +1 charge, and neutron will have 0, which is neutral. Protons and electrons will be equal, and the mass of the atom will come with the combination of the neutron and proton, which are both present in the nucleus. And then by 1869, we have known 69 elements which are all naturally formed, which are naturally available, while now we have around 118 known chemical elements, which include both natural and the artificial ones. And then coming to the naming of these elements. So John Dalton has proposed the pictorial symbols in the year 1803. According to him, he has proposed certain numbers which are as follows. And then in the year 1813, Berzelius has proposed use of the Latin words in order to name some elements. But later, IUPAC, which is the International Union of Pure and Applied Chemistry, has come up to name different elements, and they have named them using English, Latin, Greek, and German. And they've also found a format of giving the chemical symbols to them. So for example, if you take hydrogen, the first letter of every element will have a capital letter to it. And if you take copper, it is named as Cu. And if you take carbon, it is named as C. So the first letter of any element will be of a capital letter, and the second one will be a small letter. And in this way, they have started to give names to different elements because it would be easy for people to speak about the elements worldwide. And next, speaking about the atomic number, which is represented by this symbol. So atomic number is the number of protons in the nucleus of an atom, while the mass number is the total number of protons and neutrons in the nucleus of an atom. So protons and neutrons together are called the nucleons. Next one is the way you represent an element. So in order to represent an element, you will first write the symbol of the element. So here if you take oxygen for suppose, then you will be writing the mass number on top and the atomic number in the bottom. So the atomic number of this is 8 because the number of protons in it is 8, and the mass number is 16, which is the nucleons which are present. So in this way, we will be representing an element. And how do you calculate the maximum number of electrons in the shell? So it is by the formula 2n square, where n is the number of the shells we have already seen in the Bohr's model, and 8 is the maximum number of electrons in the outermost shell of an atom. So the atom's outermost shell can maximum contain 8 electrons, and the electron filling starts from KLMN because once K is filled, then only it will go and fill L. So the filling of this is known as the electronic configuration of the atom. What is the combining capacity? It is the number of atoms of hydrogen or chlorine with which one atom of an element can combine to form a compound. What is the outermost shell containing electrons? So the outermost shell which is containing electrons is known as the valence shell, and these electrons are called the valence electrons. What is an octet? So when the outermost shell of an atom has 8 electrons, then it is known as an octet, and it can either have 8 electrons or 2 electrons, and then it can be said to be as unreactive, or it is more stable in the sense it will not react much. But if it has more than 8 electrons or less than 8 electrons, then it will start to react either by losing or gaining the electrons. When it is of 2 electrons also, it is stable in nature. What is the valency? Valency is the number of electrons gained, lost or shared in order to complete the octet. So each and every atom wants to complete the octet in its outermost shell. So the number of electrons gained, lost or shared in order to complete this is known as the valency. So if the valency is less than 4, the valency number is less than 4, then it will lose the electrons in order to form an octet. If the valency, the electrons is more than 4, then it will gain electrons in order to complete its octet. So next, moving to the part that is the isotopes, which is an important part. Isotopes are the ones which will have the same protons but different neutrons, in the sense they will have the same atomic number but their mass number will be different. If you see hydrogen, you can note that we can find 3 isotopes in it, which is protium, deuterium and tritium. So here we can see that the hydrogen, here all the mass numbers are different but the atomic number is 1. So here protium is found approximately 99.98%, while deuterium is found 0.015%, while tritium is found in traces. So it is important to note that they will be having different neutrons but same protons. That is why the atomic number is same but the mass number is different. And their chemical properties are same because the atomic number is same. When you come to the weighted average atomic mass, you will observe that, for example, in chlorine, it has the mass number of either 35 or 37. With the mass number 35, it is available 75%. When the mass number 37, it is available 25%. So with this, you can find it by averaging these two numbers, but we have to find the weighted average atomic mass according to the availability. And this is how you calculate, and you get a cumulative one that is 35.5 U. So in this way, you'll be finding the weighted average atomic mass. Next, moving to the concept of isobars. So in isobars, we have the different atomic numbers, but we have the same mass numbers. So for example, the mass number of calcium, potassium and argon is 40, but their atomic numbers are different. So in the sense, they have the same number of nucleons in them. So with this, we have studied in this chapter starting from the Dalton's atomic model, Thomson's atomic model, Rutherford's atomic model, Bohr's atomic model, and then the modern atomic model, which is the quantum's atomic model you'll be studying in the future. But there's still many more discoveries which are happening in order to improve the model of the atoms. So in this chapter, the things further which are required to be remembered are the father of the Indian nuclear program is Homi Jahangir Baba, and AMU is the atomic mass unit, and U is the unified atomic mass unit which is used, and BARC is the Baba Atomic Research Center which is in Mumbai. So this is all you have to study, the important things in this chapter.